Welcome to the second video on Basic Algebra. We will start by plotting positives, negatives, and zero. The numbers we use for many computation problems defined as whole numbers, like 1, 2, 3, 4, and so on. Good way of memorizing whole numbers is a simple ruler, which starts always from 0 and increase by 1. Now assume we need to produce ice which has a temperature degree below 0. How do we indicate this temperature degree? We must picture a number line that does not begin with 0 and able to include our temperature degree. This is our new number line. And you can see there's a negative numbers to the left of the 0. And I have 3 dots here. These 3 dots showing that the numbers continue forever. And forever a mathematical term called infinity. And the symbol for infinity is number 8 written horizontally. Now, we don't call these numbers whole numbers anymore. Instead, we call them integers because we add negative numbers to the left. Now, this number is called integers. Now, I'd like to introduce a term called opposite number. Opposite number is just a number with different sign. For example, 2 and minus 2 are opposite numbers. Minus 5 and 5 opposite numbers, and so on. Now another term is called consecutive numbers. Consecutive numbers can be found by moving to the right 1 unit. 3 and 4 are consecutive numbers. Minus 3 and minus 2 are consecutive numbers. 0 and 1 are consecutive numbers. Now the trick question is, how do we write 5 as a fraction or as a decimal? How do we write 5 as top and bottom numbers without changing its value? Simply, it's 5 over 1. We write it as a fraction and the value of 5 hasn't been changed. Now how do you write this as a decimal? It's 5.0 or 5.00 or 5.00. It doesn't matter how many 0 you add, you still read this number as 5. Let's have a look into this example. Let's plot 2.5 minus 3.2 and a half. Imagine that the decimals and the fractions are numbers in between the integers. For example, 2.5 is between 2 and 3. However, minus 3.2 is between minus 4 and minus 3. Half is between 0 and 1. Now ordering rational and irrational numbers. If a number can be written as a ratio of 2 integers, it's defined as rational numbers, and you can see rational coming from ratio. If not, we call this number irrational numbers. Let's have a look at this example. 5. Can we write 5 as a fraction or ratio? Yes, it's 5 over 1. 0.2 is 1 over 5. And 0.333 is 1 over 3. So 5, 0.2 and 0.33 can be written as ratios as they are rational numbers. Now 1.4 is irrational numbers because we can't. Now you can see from the number line that as we move to the right, we increase the value of the number. So minus 1 is less than 0, and 1 is greater than 0, and 0 is greater than minus 1. So how do we say this in algebra? We use symbol of ordering numbers, and this is our table. We have greater than, less than, equal than, and greater than or equal, less than or equal. How do we distinguish between these symbols? If you have trouble remembering which one is greater than and which one is less than, let's have a look into the symbol for less than. This is a symbol for less than. And how do we write less than? We start with L and we write less than. You can see that the L is the same as the symbol, which is less than. Really match. Another way, this is a symbol for greater than, and this is a symbol for less than. If we draw a line on greater than and another line on less than, you can see that's becomes 7 and this one becomes 4, and 7 is greater than 4. So that's another way to remember. Let's have a look into an exercise. 2 is less than 5. 2 less than 5. Minus 3 is less than or equal to 3. Minus 3 less than or equal to 3. Let's do another exercise. This time is the opposite way. We have 12 less than 14. So 12 less than or equal 14. Minus 5 greater than or equal minus 8. Absolute value. Now assume I need to go from 0 to 3. I have to move 3 units to the right. Same if I need to move from to negative 3, but this time to the left. In absolute value, we ignore the direction which is left or right, and we cite and write only the unit. And the absolute value of minus 3 and 3 is just 3. Now the symbol for absolute value is 2 vertical lines and the number in between. Let's have a look into an exercise. Absolute value of 2. That means I need to move 2 units to the 2. So it's actually 2 units. Same with negative. Absolute value of negative 2. I need to go to negative 2, so I need to move 2 units to the left, which is 2. See? Negative 2 and positive 2 have the same units, because I just moved 2 units. Now let's have a look into this one. 3, take away negative 2, that means 1 unit to the left. And we ignore left, we say 1 unit. Plus 10. 3 take away 1, 2, adding 10 is equal to 12.